Math 1314, Tyler Junior College, section 3.2, polynomial functions. In behavior, the leading coefficient test. I'm going to rename it the leading term test because we're not just looking at the leading coefficient, we're also looking at the degree, both of which are contained in the leading term. Examples. On the board I have two functions. The directions are simple. Determine the end behavior of each function's graph. I invite you to pause the video and see if you can answer each. You can even look at this over here. Or remember that the the sign of the leading coefficient predicts the right end's behavior, and the parity of the degree, whether it's even or odd, tells you if the ends are equal or if the ends are opposite. Be careful, I've set up traps on both of them. Hopefully you paused the video and attempted to determine the end behavior of each of these functions' graphs. But as I warned, I kind of set up a trap on both of them. Because on both of them, it may not be evident exactly what the leading term is. And if you're thinking on the first one, I know what it is, I hope you're right. Because f of x equals 5x to the fourth minus 4x to the fifth only has two terms, the first and the second, but which is the leading term? If you said 5x to the fourth, gotcha. What makes a term the leading term is not the fact that it's written first. What makes a term a leading term is I'm the term with the highest power, and the highest power term is over here. Now, normally, well, I say normally, in mathematics, when you write a polynomial function, it's almost always written in descending power, so highest power followed by the next highest, all the way down. I say in mathematics because in statistics, polynomial functions are written in what I say is reverse. Constant term, x to the first power, x to the second power. And there's a reason for that. And there's even some spots in calculus where polynomial functions are written that way out of necessity because they're infinitely long, so technically not polynomial functions. But I digress. The leading term on f of x is not the first term but the second. And we can do one of two things. Locate the correct box or interpret the leading term's properties. If we locate the correct box, the leading coefficient is negative, the degree 5 is odd, so the left, it rises left and it falls right. But if we were to analyze it, this negative tells us that it falls right, because that's what the sign of a leading coefficient tells us, what the right end does. And this degree being odd means that we have opposite ends. Remember the alliteration. Opposite and odd both start with O. So it doesn't take too long to determine the end behavior. Therefore, I think I've shown you the three-dot triangle before, but it's the mathematical symbol for the word therefore. Usually means we're about to answer a question or draw a conclusion. Therefore, because the ends are opposite, we know that this rises left, because we already determined that it falls right. It's not wrong to list the right end behavior first. It's typically written left first and then right second, though. So did you get that one, or did I fool you? If I fooled you, it's okay. I didn't demonstrate one like this. But now you've been warned, don't fall for it again in the future. Now this one might have taken you a little bit more work if you knew the trap that I was setting for you. The trap on this one is that this polynomial function is not written in general form. It's not written highest power, next power, next power, next power. This one's factored, which under some circumstances is what we need, but this isn't one of them. In order to determine the end behavior, we need to know the leading term. We need to know the term with the highest power if this were entirely multiplied out. Now, if you saw through that, then you might have started multiplying it all out. And maybe you came up with the correct leading term, and that would be great. But what if I told you we don't have to multiply it all out? I don't need to know the whole function, I just need its leading term. So is there a way to get the leading term out of this without multiplying it all out? And the answer is yes. I'm going to write a sentence to say what I'm about to do. If a polynomial function is factored, polynomial function factored, meaning it's a multiplication problem, this one is, then its leading term is the product of the leading terms of each factor. In other words, I don't have to multiply it all out if all I want is the leading term. I only have to get the leading terms of each factor and put them all together. So how would that look here? Well, the first factor is negative 4x to the third. You could argue it's just negative 4, but we'll grab the largest monomial that we can. The next factor is x minus 1 squared. Being squared means it gets written twice. Now there is a way to avoid writing it twice. I'll explain at the end. And the last factor is 3 minus x. So if I want the leading term of this, all I need to do is multiply the leading term of all 4 factors. 1, 2, 3, 4. The leading term of negative 4x to the third is negative 4x to the third, because in this factor, a monomial, it's the only term. So for our leading term, we're going to start by multiplying that. What is the leading term in x minus 1? Well, the highest power in x minus 1 is x to the first, so its leading term is just that x, as is the one over here. What's the leading term over here? Careful. It's the negative x. It's got a power of x to the first. This has no x's. So all I have to do to put together the leading term is multiply negative 4x to the third times this x. Now I mentioned that you don't have to write out the x minus 1 twice, because if you're going to yank out leading terms from factors and your factor has a power, just put the power on it. I could have just written at this once, but remember that I'm going to have to put a square on it because that factor was repeated twice. And of course the leading term over here is negative x. Now I shouldn't write equals because this product is not equal to all of this. That's just the beginning of it. I could write plus dot 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 to say that there's more multiplications that I don't care about because I'm only looking for the leading term. So let's see what this product is. Well, first off, negative times negative is positive. Coefficients, 4 times 1 times 1 is 4. Or you could have said negative 4 times 1 times negative 1, but that's still 4. Now for the power, we just have to add the exponents. So 3x is here, plus 2 more, plus 1 more, is a total of 6 x's. So this polynomial function's leading term is 4x to the 6th. What's the rest? Again, don't know, don't care. Because if I'm just looking for the leading, for the end behavior, I only need to focus on the leading term. So what can we deduce from this leading term? The leading coefficient is positive. What does that mean? That means the right end rises. So it rises right. This 4 being positive means that it rises right. But the degree is even, and what does that mean about the ends compared to each other? That means equal ends. So if they're equal ends and the right rises, that if it rises right, that also means it rises left. So end behavior is predictable if you know where to look and what to say when you look at it. It's all about the leading term, and more specifically, the sign of the leading coefficient, and whether the degree is odd or even.